All right, we got MTS chapter 10.3, ALG2, homework 10.3 question, and right now this is just going to be question 35. Okay, and so with this question 35, we had this thing where we were in New York City, right? And one thing about a spherical problem is that you have these latitude and longitude lines, right? And I believe these are latitude going around east to west. Not sure. So, but the point is, they start at 0 and they go up to 90. So you got 0 degrees, 10 degrees, 20 degrees, all the way up to 90 degrees, right? And we're on the 40th degree, right? And so, and we're doing, 20, so let's say this was 90, and it went down to 80, right? And then 60, for whatever reason, it went to 80, and then 60, and then 40, and then 20, and then the equator, right? And so when I was doing this problem, we were trying to do it with the whole, there's a New York City right here, right? And then we're doing the radius of the equator. I was like, oh, radius, that means half of the equator. And I'm like, no, it doesn't. So that's one part I got wrong, right? I was thinking half of the equator was going to be 4,000, right, miles is the radius. Okay? And then I started thinking, wait a minute, no it's not. That means the radius. That means that there's a circle, right? And that's the equator. And the radius is 4,000 miles. So then I was like, oh, okay, so then I'm going to do this. And then because we are on the, 40th latitude, right? 40th degree, this must be 40 degrees. So then I solved it that way. And I was like, well, that's wrong. And I was like, well, what's going on? And then I started thinking, wait a minute. This is a problem where this is the radius of the circle, right? And then it goes up, because it's a sphere, there's two circles. There's a circle going this way, right? And there's a circle going this way, right? Because it's a sphere. It's the Earth, right? And so half of that radius is going to be 4,000, right? And so it's a 45-45 triangle, right? So then that's how I solved it. And I was like, there it is. No, that was wrong. So I was like, what's going on? And then I realized, because I knew that there is a curve, right? That there's a curve. And I know spherical geometry, but I also know you guys can't handle spherical geometry yet. I mean, we're not there yet, right? We're not going to do non-Euclidean geometry, right? Or are we, right? So I'm like, okay, maybe we'll do the arc or the secant. So let's say we have this 45-45, right? But there's this piece that we want to find the length to. So I started thinking about that. Oh, we could do the secant. And I'm thinking, wait a minute. It's so much easier than that. So then I was like, okay, what's going on here? We're talking about a radius of a circle, right? Okay? Now, this is the distance to the North Pole, not to New York City. New York City is right here, right? Which is like this on the triangle, right? And so New York City oh, similar triangles, right? So I started thinking, wait a minute, so if it's similar triangles, this shape is also similar, right? And so therefore, what's the proportion that's going on between these? Well, we know that there's 90 degrees, right? So there's 9 portions. We're on the 40th degree, right? So 4/9 of it. So from here to here is 4/9 of the total distance, because it's similar triangles, right? So I'm going, okay, well this is really easy, because what's the circumference of a circle? So the circumference of a circle is equal to d pi, right? Well, what's the diameter? It's 2r, right? D is equal to 2r, right? So then, when you were saying, oh, it's 40 degrees north, I was like, oh my God, that's so right. So I did it that way wrong. It was the right thinking, though. It was the right thinking, because you're right. I was thinking east, right? I was going, oh, it's 40 degrees, and I was thinking east, and I was like, oh, what a dummy, right? So I was like, no, it's 40 degrees north. And I was like, and then that didn't work out. I'm like, why isn't it working? And then I realized, wait a minute, this is a triangle inside the earth. So, and someone had a ball, so I was showing them the ball, right? And I'm like, oh, this is so much easier than that. So what it is we're talking about a quarter, right? This is a quarter of the circle, right? So then I'm taking the quarter of this, right? That would be a quarter of the circle, right? Okay? So then I'm going to go, okay, well, then that would be just 8,000 pi over 4, which is 2,000 pi. Okay? So that's how long that distance is from there to there. From the equator to the North Pole. But then I had to multiply by what? 4/9. Right? And once I did that, I got the right answer, which let's just do the math real quick, I guess. I did it on my phone yesterday. My phone's in my car though, so I can't do that. So hopefully this has a pi. Does this have a pi? Yeah. Yep. So we go 2,000 pi, right? Times 4 divided by 9. That should work, right? Yeah. Alright, so then that's 27.92.5, right? 92.5, but they did it in closest mile, so that would be 2,793 miles to go from New York to the equator. And I'm like, that has nothing to do with sine, cosine, or anything. Thanks for wasting my 2 periods on a problem that has nothing to do with the stuff you're teaching in this chapter. But it was still kind of awesome, so I thought I would show it. Okay? I won't be putting a problem like that on the test.